Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video where we're talking about mass percent. Mass percent is a measure of concentration. As you know, molarity is, so is mass percent. Mass percent is the focus of this video because it's usually confusing for many students. There's a good formula out there to determine mass percent. Let's look at that. Mass percent of a solute is equal to the mass of that solute in grams, and we can use the word solute over here, divided by mass of solute. It's an easy formula, plus mass of the solvent. The solvent is the item into which the solute is dissolving, but notice here the denominator is also equal to the mass of solution, because the solution, you know, is made up of a solute plus a solvent. So the mass of solute divided by the mass of solution, or mass of solute divided by mass of solute and that mass of solvent, will give you the mass percentage when you multiply it by 100. So that's a formula you want to keep in mind as we look at two questions in this particular video. The first question is this: what is the mass percent of sodium chloride solution using 133 grams sodium chloride in 1 liter solution? You would have to know density normally to do your calculations involving mass percent, and the density here is 1.08 grams per ml. How would you go about determining the mass? Well, you need to know the mass of solute and the mass of the solvent. We know the solute mass here, it's provided, it's 133 grams. But how can you determine the mass of the solvent? You can from the volume of the solution. Remember, the solution is made up of here a solute plus solvent. We know what the solute is. We can easily determine the solvent. You have to convert this liters into grams, because everything must be converted into grams over here because we're talking about mass. 1 liter of solution, and we are looking here at milliliters, so you have to convert the liters into milliliters, times 1000 ml per 1 liter of solution. I'm abbreviating SOLN. Bring in the density factor to bring in the grams, times 1.08 grams of that solution per that ml, and see what happens. This cancels out with that cancels out with this, and you get exactly in terms of the grams of the solution, the mass of that solution. You'll do 1000 times 1.08, you'll get 1080 grams solution, and that's what we have. But look right over here, the solution is made up of solute and solvent. We know we have 133 grams of solute. What must be the grams of the solvent? It would be 1080 minus 133. And what would that be? It will be 1080 minus 133. I'm getting 947. And now I have everything I need for that formula. Mass percent is equal to mass of solute divided by mass of solute plus mass of solvent, or the mass of the solution. You would do 133 over 133 plus 947, or you could have just done 133 over this figure you've determined, 1080. And you multiply by 100, and that'll give you exactly the mass percent of sodium chloride in this solution. And it'll be 133 divided by 1080 times 100. You're getting 12.31% NaCl mass percent. So in this solution, which is 1 liters in volume, 133 grams of sodium chloride, it is 12.31% by mass sodium chloride. Therefore, it is the other remaining percent, your solvent, which would very likely be water in this case, even though we've not mentioned it. But this is exactly how you would do this type of question. Let's look at the second question over here, which will bring in the molarity concept along with the mass percent concept. How can you correctly make a 1 molar sodium chloride solution? It would seem intuitively that it's easy, but it is not, because many students will make a very common error. We have to assume here density is 1.02 grams per ml. The very common error which students will make is in terms of molarity, which you know is moles over volume. The problem is many students will think that this is volume of your solvent, and that would be wrong. This right here really implies volume of your solution, your total solution, and you know now solution is made up of your solute and it's made up of a solvent. So that's something which has to be kept in mind. The definition of a molarity is moles divided by volume in liters, but you're not looking at liters of solvent, you're looking at liters of solution, which is comprised of your solid portion and your solvent portion. So that's a very important peculiarity that you need to keep in mind. Generally, what you would do is you would look at 1 molar in terms of 1 mole of sodium chloride divided by 1 liter of solution, and that will give you exactly your 1 molar salt solution. You would basically have a little flask over here, and you know, we can draw a flask. you would put here 1 mole of sodium chloride. What's 1 mole of sodium chloride? It's equal to mass divided by molar mass, molecular weight or molar mass of sodium chloride. It's equal to 58.5 grams per mole. And that tells you exactly mass over here will be, this going across will be 58.5 grams. So you know you have to use 58.5. We don't have to be 100% accurate with the decimal places. 58.5 grams of sodium chloride. To make a proper sodium chloride solution, what you have to do is put in 58.5 grams of solute, which is right here marked 58.5 grams. Here's my 1 liter mark right here. Then you put in enough water to fill everything up to this 1 liter, and that's how you would make it. But that's not 100% our question solved over here, because we have to do the math behind it. You cannot make the mistake of putting a 1 liter solution and then you add 58.5, because what would happen in that case, if you were to put in your flask up to this 1 liter mark water first, now you add in the salt, your line will go above, your volume will go above by this little extra amount. That little extra amount will end up reducing your molarity from 1 to something else. You will not have a 1 molar. You'd put first your solute, 58.5 grams of it, then you'll add enough water to raise it up to this 1 liter solution mark. And that's how you would do it. But how much is this enough water that we need to add in? Given we'll already have 58.5, well, that's where the mass percentage calculation will come in the density part. You know the mass percent, let's abbreviate. Mass percent is equal to mass of solute divided by mass solute plus mass solvent. We know what the mass solute is, it's 58.5. We know we have to somehow determine the mass of a solution. If we have 1 liters of solution here, as you know, we have to convert everything into milliliters again, because we have the density factor coming in here and everything is in grams per ml. You'll have 1000 ml per 1 liter of that solution. And then you have a density factor here, 1.02 grams per ml of that solution. Look what ends up happening. The liter solution, that and that cancels out. You end up seeing over here 1020 grams of solution are coming into play. How do you know how much of that is solvent? Well, it's not hard, because you know you already have 58.5 grams of solute. You'll do 1020 minus 58.5 grams, and that will give you the grams of solvent. And let's put this value down. You'll have 961.5 grams of solvent, which I'll assume to be water. To make a correctly fabricated 1 molar sodium chloride solution, you need 58.5 grams of salt. You need 961.5 grams of water. When you combine these, of course you'll put the salt in first, then you'll put 961.5 grams of water. By means of this density factor we've already accounted for, everything will rise up right here to this 1 liter mark, and that's exactly how you'll get your 1 molar solution. If you ended up putting 58.5 grams of salt, but you put a full liter equivalent of water, which in terms of density factor of water is 1, you'll be putting 1000 grams or 1 kilogram of water or 1 liter. You'll go above the mark and your solution will be diluted. It won't be 1 molar, it'll be less than 1 molar. How can we check everything over here is good? But this is how you'll do it. You do 58.5, you add it to your grams of water, 961.5. You're coming here with a value in terms of, but don't forget, sodium chloride is not pure water. It has a density larger than water. You'll divide this by your density factor to get rid of the grams and bring in the volume. And you'll get exactly 1 liter, and you know now you're right. So if someone were to ask you how can you correctly make a 1 molar sodium chloride solution, your answer should be you always put the 1 mole of that solute and then you put in enough water to arrive at that 1 liter solution mark. You never put 1 liters of water first and then you put your solute, because you'll go above that mark, and that's a very important concept that you need to remember. It has everything here to do with the mass percentage. And that right here is all I want to present to you in this video. Thank you for watching.